just me in the suit today. It's winding down before Christmas. There's not a lot of us left. Chris is gone. He left me to my own devices. And my ambition today is to not screw the stream up completely. Um, Also, not bump into the mic all the time. So, well, you might have noticed we missed the community stream last Friday, mostly because I was hungover beyond belief. We had our Christmas party on Thursday. It was epic. But also, during that Christmas party, we sort of went through the hackathon that we all did, and a lot of cool stuff was done. Like, it was really impressive. Like it always is, but it's like I'm sitting there just like watching amazing stuff happen in front of me. It's always really exciting, and I kind of wanted to share some of those things. Some of them don't really make it, they don't really work in a stream context. But because I mean, Chris was doing like really cool like database level data binding, so you can just data bind to queries, which is, I mean, it's prototypical, but it's very cool stuff. We had a lot of like UI generated off of backends and really interesting things. But I figured we'd have a look at some of the things that are a little bit more visual. And of course, I'm doing all the switching myself today, so pardon the jank. Yep, there we go. So one of the things that we've been sort of having in the pipeline for a long time now is this sort of custom shader pipeline. It's like Uno has all these graphics programming features built into it. They're a tiny bit esoteric and they require a little bit more education than you might need if you already know how to program things like GLSL. And Jake put together this sort of shader toy-esque. Shader toy is essentially like a web-based front end for prototyping and sharing shaders and graphics programs. And this is, I mean, it's not really productized. It's very well documented, I'd say, for something that was done during mostly a hackathon. But it's a really cool thing. Like this small project here, of course, open source everything. I'll put links for all these hackathon things in the description for the archives for this video. But yeah, it was, you can see here, like interactive, real-time, like GLSL based shader effects. And every effect you can see here is in the source code as well. And it's pretty neat, especially in terms of, I mean, if you're not a graphics programmer, a lot of these terms are going to be a little bit sort of wild for you, like understanding like what even a buffer is, or even honestly, I mean, you'd have to learn GLSL to be able to use this. But if you do know GLSL, this is a very friendly entry into writing like real-time effects with Fuse in a way that I think makes it a lot easier to like get into than if you were doing the same thing for something like iOS and Android. And this is, of course, it has like live reload and all that good Fusey stuff. So that's pretty sweet. Also, Erika Mortare has been working on these really cool like curve animations. And this is a pretty long video, but some of these are amazing. I really like this one right here. So this is stuff that will be possible with Fuse hopefully very soon. I mean, clearly it's already possible, but productized is a different thing, right? But you see stuff like this, and it really, like, as even a person working at Fuse, it's really inspiring to just see, like, if you just give people, let's let people work on whatever the hell they want to work on, you wind up with just really cool stuff that in the end is going to benefit you guys. So this is, I'm really looking forward to be able to actually play around with this stuff myself. So that's cool. By the way, Mortare is running his own stream on Twitch as well, where he goes through, I think he did a stream about this exact topic yesterday, and I don't know if the archives are up for that yet, but if they are, I'll put them in the description as well. As for me, I wound up making, so guys, I keep fumbling around trying to find colors for things. So it's like, red, blue, and it always winds up looking like just an absolute horror show. And I'm really a fan of like sites like colors, adobe.com, and like coolers.co and stuff like that. And I just wanted to sort of replicate that in sort of a Fuse API. And this is, again, just me wishfully thinking like, what if I just have Fuse generate colors for me that make sense, because I'm lazy. And I wound up making this sort of simple sort of palette generator based off of these sort of rules. So like complementary colors, where like the top color here is sort of the primary color, and then everything else is sort of based off of that one by rotating the hue around a color wheel. It's if you've seen colors at adobe.com, this is pretty much that. And you know, being able to eventually find something that maybe I can work with, and then have that somehow generate UX markup or something that I could just reuse, right? And I got this thing where, you know, I can tap the thing and it gives me print palette. I look at the log and it prints this stuff right here. And I can just take that and conceivably copy paste that into a document, and there's my palettes, right? So that's the thing I made. The thing about this that was like fun to do, of course it's just fun to make this UI stuff, but if you look at the actual layout here, there is a Fuse Colors palette object and there is a Fuse Colors editor object, and that's kind of it. And the thing that makes these interesting, we should actually look at the source for this real brief. Hold on. Oh god, too many Visual Studio Code windows at once. There we go. This is all the UX markup for this, right? So outside of the status bar config, but here's my palette. I give it a name. In this case, I've set a base color for it, which sort of like offsets the hue. So if you have a color you like, you can base your palette off of that one. But the entire UI is this Fuse Colors editor, and that's also defined as part of this Fuse Colors package. But all this does really is take a palette as a dependency and data bind to like controls on that thing. So we have all these editor sliders that are bound to palette gain RGB and so on. And the palette itself is just a .uno file, right? So there's a lot of stuff in here, so I'm not going to go through this in detail. But this is the thing. It's a palette that extends panel. And if you're unfamiliar with Uno, this is not going to be like a hardcore Uno stream or whatever, but I want to like illustrate the relationship that Uno has with UX markup, because it's a very important part of understanding how Fuse functions as a platform, and it might also inform how you write your UX markup as well. Or maybe, you know, it'll change your appreciation for the platform. And the reason I wanted to make this, like talking about this relationship between Uno and UX and how they communicate, is our new preview app. And we did a new, you might have noticed 1.5 is out. It was like a big day for us. It's like get the hackathon done, everybody gets drunk, and also put out a new release. It's a lot of stuff. So in 1.5, I'm just going to close this guy for now. You might have noticed this new devices button up here. And what this really does, like in the past, if you tried to do a device preview, right? Like you want to run your app on your device to see what the colors look like in this case, because I mean, this markup is really just a bunch of rectangles with some colors on them. I'm going to close this other guy. Go away. And you'd have to like build a version of your app. Like you'd make a preview build essentially. So you'd go up here and you'd do preview on Android, and that would build for like ever, and it would finally deploy to your device, and then you have the live reload, and you know that's fun. But like at the same time, you have to install the Android SDKs, you have to install you know, Xcode, you have to know what Xcode even like how to navigate Xcode to really use that feature. And I'm gonna try something that's probably gonna look real janky, but bear with me here for a moment. So let's see what this actually looks like when you're using the Fuse Preview app. And whoa, there we go. Well, the aspect ratio is all weird, but you're just gonna have to deal with that. So we have the preview app that looks like this, and whoa, that's nice fisheye. And you can go scan the QR code, and you get the scanner. Where'd my QR code go? So we're gonna hit devices, look at that, and there you go. It just kind of works, right? And all the live preview stuff that you kind of know and love is all right in here. So going in here and picking one of our rectangles and changing the color to some hideous red, because that's always what I do. And we go back to our app, and you can see it's now updated, right? And you could conceivably switch between multiple projects at the same time. Like you just shake it a bit, you get this little menu. Well, you have to like actually get it, hit home, and then you're back to, you know, where you can scan for another application. So I don't think I need to tell you that this is sort of a game changer, right? This really means, whoa, cable spaghetti, sorry about this. It's the first time for everything. What this really means is that if you're developing only on Windows, right, then suddenly you can run this preview app on an iOS device and you're now an iOS developer, right? But as we put this stuff out, people have started to encounter some sort of natural limitations of this. Like, how come, these packages don't work? Like, I have all these packages in my project. Why doesn't this app understand, like, that I want to use this third-party extension or whatever? And that's because the way Fuse actually builds applications. And this feeds into how the relationship between UX markup and native code. Yeah. First thing to understand is sort of the pipeline. So you have UX markup at the top. And UX markup is, as you can see, it's this pretty straightforward declarative language that declares some properties and declares some relationships between objects. But what this actually winds up generating, if you look under this .uno in UX13 here, we have our main view.g. It generates this. And this is sort of like a lot of boilerplate right here, just setting up stuff so you can easily reference them. This is not stuff you should ever have to look at, but for the purposes of illustration, it's worth looking at right now. Because at the very bottom here, we have this initialize UX function that does what our UX document said, right? Like, it creates these rectangles up here, it creates the grid, creates the rectangles, it adds the rectangles to the grid, sets the row count property on the grid, and it sets the color on the rectangles, right? So you have to understand then that UX markup is a language that generates Uno code. Uno code is the language that we use to generate native code or .NET code based on whatever platform you're trying to target. So from this Uno code, we are generating essentially like C++, in some cases like Java, or the bindings between these languages. Like, Uno is a very it's not necessarily an extremely complicated tool, but it's a dense one. There's a lot of functionality built into it, mostly for us, but that's also obviously now exposed to you guys if you're willing to learn. But the thing here is that you could create a new Fuse controls rectangle, and all I put in here was rectangle, right? You kind of understand that there is a direct correlation between types that Uno can access and types that I can instantiate in UX markup. And the thing that happens in a live preview is that, in the preview app, is that we have bundled like a set, like a very specific set of what Fuse can do into that app, so that when this UX markup is evaluated by the preview app, it already knows about those types. They already exist on there. So instead of having to actually compile much, it just kind of finds the existing stuff and bolts it together in the same way that this file does. And this makes it incredibly fast. There is really no compilation whatsoever. It just takes stuff and instantiates it. So any sort of overhead you're going to have with like switching between different projects using the preview app is really tied to the complexity of the instantiation of these objects and setting up those relationships. And the limitation obviously there is, what if you write your own custom Uno code, right? Like, what if you have your own custom stuff? What if you want to use some third-party library that we haven't bundled with our app yet? Or maybe we never will bundle that, right? You're still going to have to use the old preview way. I would say this is a trade-off, right? So with Fuse Preview, the app, you're going to have immediate access to, I would say, like 90% of what makes Fuse Fuse. Like, is this the live reload, quick workflow, like great looking, easy access to building interesting like UI. You can be able to test it on all these different devices really, really quickly. Like, it's really going to accelerate your workflow and simply getting stuff into your hands so you can look at it on a real device. But I don't want, when I'm thinking about Uno, like for me, like the reason I chose the approach I did for the hackathon was because I wanted to exploit that relationship, because I think it's very interesting, and especially if you're already a developer, you might be tempted to. I mean, this makes more sense if we just look at an example instead. So I'm just going to clear this project right here. And let's do sort of like a hello world. Let's create my first node in UX. And I'm doing a lot of this from memory, so if I stumble, please forgive me. So I'm just going to make, I guess hello world will be something that adds, let's say something that adds a couple of numbers together. It's completely trivial, right? But if you were going to do an add in I don't know why you would do an add like this, but hey, you could either do it like through a round trip with JavaScript, which would be slower. Maybe you want to do it in like the most native way you possibly can, but you still want to do the data bindings in Uno. And this is where extending nodes and extending behaviors and so on comes in. So we're going to call this thing adder.uno. We're not going to have a package for it. I'm going to try and keep this very, very light, just in terms of the actual features of the language we're going to be using. So I'll be going fairly slowly. But we want a public class called adder, and it's going to extend behavior. Now, why are we choosing a behavior? The behavior in UX markup is sort of a node that doesn't have anything to do with layout. It's a thing that decorates its surroundings with some sort of information, right? Like, it's essentially like anything that doesn't have a visual representation. Like a panel is like a layout element, but you can put a behavior inside of a grid, and it wouldn't like automatically consume a column or a row or something, right? And to be able to use our behavior, we're going to have to import or using Fuse like this. And just for the future, we're also going to have to use a package called Uno UX. Save this stuff up. And just to make sure that this stuff actually works yet, we'll go back into our main view and we'll just make an adder, save that guy, and we can go back into, let's not do this in the workspace, come to think of it. Here we go. And already now I'm breaking everything because, again, it's trying to auto reload, but it doesn't actually know about the adder.uno type yet because we have to recompile. So quickly in Fuse Studio, that's Command-Shift-R. It's going to spin this up. And lo and behold, we have nothing, right? Which is pretty much what we expected, but it didn't complain. Like, we got away with it so far. And if you want to actually make sure that this actually worked, we can do, we can kind of hook into the life cycle of a node in the UX tree. So if you ever did Flash or anything else that worked in sort of a tree structure, you would typically get an event when something has been added to the screen or removed from the screen or like added to its parent node. And we can access that as well in this Uno. So override protected void on rooted. And we're going to call base on rooted as well. So we just passed this on, but I'm also going to trace, or sorry, debug log. You can hear the Flash developer in me. I got rooted. Save this. Command-Shift-R. And this is going to get called once this app spins up again. Hope this isn't too small for you guys, but you should be able to at least read. There we go. I got rooted. And see, this happens twice. So once when the actual app starts, and then Fuse is kind of poking at the screen to like reevaluate the screen density and make sure the layout is correct, and then it gets rooted again. So this is just going to be the first time. Great success so far, right? Like, we have a node in our tree that does currently nothing. We don't actually need this on rooted for anything in this example, but if you were doing something that like, you notice I didn't make a constructor for this. I didn't do like a public adder and then do a lot of instantiation in this, because typically like in Fuse, if you're creating a node, you want to hook into onRooted and onUnrooted, because it only means something once it's like attached to a context. And when it loses that context, it should like detach itself, like remove any event listeners or anything else that you were listening to. And if there are questions going on in the chat right now or something, I'm sorry, I'll have to get to them at the end of this. What I want to do with this adder is I want to take two numbers and I want to output a third, and I want to be able to data bind to that third one so that when I change any number, like it all just updates, right? So we can just go back into our main view for now, and it's like we need some sort of UI just to kind of test this. So I guess we'll make a grid of 2 columns, and let's just make a grid of 2 rows as well. So at the top here, we're going to have 2 texts. I guess I'll use text box and just have a temp value. So A value and B value. Say that guy. Boom, boom. So we're going to fill in A and B in here, and we're going to print in the third text box the result. right? Good so far. Now, how do we bind this stuff up into the adder, right? So we need 3 properties on the adder. We need a public, I guess a double is the type we want to go for. Public double A, which we're gonna have, this is a property, right? So we can't just like make a field and it'll work, because we need to be able to hook into sort of when this value is being set and when this value, more so than when the value is read, but you get what I mean. And we're gonna have a temporary, like a sort of a local field that we can store this value in. And we have our getter, we have our setter, and when we get, we're just gonna return A. And we set, we're first going to check if A is already the value. So we're not going to do anything if the value is the same. So if A is value, just return. If not, we're going to do A is value. And we're going to repeat this twice. So we're going to have a B as well. Great. B, like that. So now we have our A and our B, and we have a final result, which is a public double result, but we only have a getter for this, because you're not going to be able to set the result. Like, we're not going to generate whatever A and B is. So this is only going to be a read. This is going to be a read-only value, right? So get, we're going to return result. And you'd think that would be it in a way. All the defaults for these are going to be 0, 0, and 0, so it's all going to be technically correct when we start off here. And already now I can start data binding stuff. It's not going to work, but I can start data binding. So the value for this should be the, oh, we need a name for our adder. Let's go with myAdder. And we're going to data bind to the property myAdder.a. And we're going to have this guy data bind to B. And for this, we're going to data bind to result. Save this, and we have to recompile. See, this is sort of the workflow when you're working with Uno. You do have to rebuild every time you make an Uno change. But once the Uno is compiled, you have all the live reload in the world, right? It's just something you have to be aware of when you're working. Here we go. So there we go. As expected, we have 0, 0, 0, but nothing's really changing here. Only we got errors here because I tried to try to type text in here. I was trying to cast that text into a double, which is clearly not going to work. So our next step then is, how can we make this change propagate so that this value changes, right? And when you extend something like behavior in Fuse, you have access to, well, it's sort of a 2-step process. First off, you have to like give these properties that might change or that you might want to listen to, sort of like a unique handle. And this goes through what we call selectors. So it's called result in this case. I'm going to make a static selector. I'll just call it result name, because this is going to be the handle for the result. That's going to be a new selector called the same thing, like this. And I'm going to make a function here that's going to essentially poke at the system and say, hey, the thing called result changed. I'm just going to call that update. And I'm going to do, let's have a look here. Yeah, so that would be on property changed with result name, like this. And we're going to have to call update whenever A or B changes, like this, right? So when update runs, see, we're not actually calculating result yet. So when update runs, we're going to calculate the result, and then we're going to tell people that result changed so that it can be read. So I'll do result equals A plus B. Save that guy. Rebuild again. It's always a good time. We are good to go. And seems like I have forgotten something here. There's always one thing. It's like the demo ghost. Like every time I think everything's going to be amazing, there's always something I forgot. Oh, right. Sorry. I guess I do need a setter for result here. We're not going to do anything in it though. I wonder if results like a reserved name or something. Now, there we go. So now 2020, 21, 25, see. So I mean, we still have some validation to do here. We're getting problems every time each of these is like empty or something. But I mean, it's also recovering from it. So, but now there we go. I mean, if you can actually tell what's happening here, I'll make this text a little bit bigger. Boom. So I can make all these duders bigger. Like, yay. So I think that's really cool. Like, in terms of how little work that is. I mean, of course, this is a really contrived example. Like, you don't have to do additions using custom Uno code, but I think just to illustrate how you can write some code and have it just recognized in the UX as just like a natural citizen, right? And actually, if we go back, I think it's been updated for now. No, I might have to actually rebuild part of this. So I guess local .NET. Oh, right, sorry. I'll just poke at this. Just so we can have a look at it. So now looking at this, I mean, it's doing the same stuff. It creates a, where's our guy? Where's our guy? I guess the order it instantiates these things isn't, oh, there we go. So we create our MyAdder, and we set up the bindings through these fuse reactive data bindings. Like, again, this is not, you know, you're not supposed to write this kind of code, but just kind of show that the UX compiler, when it looks at this, just kind of like, oh, this is how I built this together, because it has understanding about how classes and objects and properties work together. So I think that's a pretty sweet thing. And this sort of, there's a bunch of like art to this, right? Like, if you're trying to build a really involved, I mean, I guess I should just also point out, this is how a lot of, if not all, the like native controls and sort of like local, like you know, how we wrap the web view and so on, that's done through this methodology. But that also has a lot of implications, right? Like, so there are things here I haven't touched on. Like, I'm simply calling on property changed here. We do have a separate concept, which this can get involved when it becomes a scenario where you potentially get like, you know, infinite loops where you're like, we're doing double checking here. Like, if this double is the same as this value, like that is unlikely. Like, you're gonna have like, maybe you're casting a double to a float and back again, you're suddenly losing precision. It's not gonna be the same value anymore. So you could have a situation where you have like an infinite sort of loop, right? Like, where it's setting a thing and it's bound back to something that sets itself back again, and God knows, like, not in this particular scenario, that'd be unlikely, but it's something to keep an eye out for. And we do have mechanisms that fix this, but it does get a little bit more involved. And you kind of, we have a principle of sort of like the origin. What is the origin of this event? And of course, all this stuff is open source. So if you do want to have a look at how we how we do this sort of data binding stuff, like, you could really just search for onProperty changed in the FuseLib source code, and there's a lot of interesting stuff in there. And this is sort of like the high level of what I wanted to touch on today. It's not going to be a particularly long stream this time, mostly because it's just me. But let's see if you guys have any questions for me. Nope, nobody cares. But I figured this stuff would be a fairly sort of nerdy topic to hit on today. I guess we can look at how a little bit of the JavaScript stuff works too, now that we're touching on this business. So if you get back to my Fuse Colors project, just close this guy. And the JavaScript that actually happens in the palette editor, again, the editor is the sort of the UX, the involved UX part of this. I suppose I can run a preview of this as well. There's not a lot of JavaScript in this thing. Like, it's mostly like state. Like, in this case, there's some tests in here that I should clean up, but it's also like which mode is current, and like, am I expanded or not? Like, what's the what's the state of this component, but it doesn't really care much about the innards of the palette. The palette does, however, have some functions on it. And I'm passing in this palette through this dependency, and I have these print settings and print colors functions, right? And those call palette get colors. So how can I do this? Like, how can I write a custom Uno node that is actually like can respond to JavaScript like this? And it's like more like memory than like complexity at this point. And this is actually a sort of an overwrought signature right here. But essentially, you have to make what's called a static constructor. So this is a constructor that's going to be run once for the type itself. And it's calling this script class.register, and it's going to register some methods on this object's type. And I'm going to just like kind of brush over this because it does get pretty involved. But you can see it's really just saying, I want this type to have these script methods that are tied to this type. So like remember the type this thing is coming from. And it's going to bind them to, I don't think we actually need these castings in here, just to clean this up a bit. Yeah. We're going to say this JavaScript method is going to call this Uno function, and is going to run that function on the JavaScript thread. So this is important, right? Like being able to know in what context or what thread some code is going to run is the difference between an app that crashes or not, or you know, where it just doesn't run well. And other than that, like it's fairly straightforward. Like you have your get colors, it receives a JavaScript context, it has a reference to the object on which that method was called, and the arguments that was passed into the JavaScript function. And in this case, like getColors doesn't actually take any arguments, but you still, since you can pass as many arguments as you want to anything in JavaScript, we still have to accept this object array. And we're using the context to create a new array, and we're just using the sort of standard array notation to just bind stuff on it. So I'm just going over all my colors and adding arrays to that array and setting some fields on it. And then I'm returning that, because the return type of getColors is just object. So there's a lot of like trusting the Marshal to like look at these types and converting them into more like JavaScript, like types that are sound to the JavaScript world. And I put all this stuff, by the way, I actually, like once I wrote this, I don't know how useful it is as like an actual like palette generator for people, but I think it's a pretty nice example of what you can do with Uno to create custom nodes. So I did put all this stuff open source, like as one should. Hey, you do love me. Hey guys. Yeah, there's a dots in your head from an iOS library to Uno to UX. So this is sort of where you combine the UX markup with foreign code, right? So if you haven't looked at foreign code, I guess we could try. It'd be kind of tough to demonstrate here. I guess I could do a simulator build just to kind of have something. Yeah, let's do that. It's fun. Let's have fun. Let's have fun, you guys. So we have our custom node project, and I'm going to make first, we're going to start this as a local preview while I'm just kind of testing stuff out. So instead of our adder, what is like the dumbest possible thing? What if we have native implementations of adding? That sounds appropriately ridiculous. So we should totally do that. This is the dumbest thing. Okay, well, we're gonna make a something that takes two doubles and returns a double, right? So we'll make our sort of .NET implementation of this. So double add is taking a double of A, the double of B, and returns A plus B, right? And then when we're getting result, we're gonna call add with A and B. So now we sort of like moved where the magic happens into this function. What we can do, I can exit Uno export target interop. Hey, join me on an adventure as we look at the FuseLib's public source. Hang on. My memory's terrible with names. Like, there we go. Uno compiler export target interop is what we want. So we're gonna need that function as well, that package as well. And if I can type correctly, that'd be cool. Using Uno compiler export target interop. And now we have access to foreign code. So in this case, there is no like, this is the function we're going to call if we're not doing anything natively, right? So I'm going to actually debug log in this and just say, this is a .NET implementation in this case, or yeah, let's just leave it at that. And we'll say, this is a function that's only going to run if I'm not on mobile, right? So if I'm not on mobile, this is the function. If I am on iOS, I'm going to have this other one. So we're going to do 3 different implementations here. Extern, iOS, same signature again. Actually, this would be silly if we didn't use the same signature. But the difference is, in this, we're going to have this be foreign code, right? So it's foreign language C, I think it's what it's called. It's been a while since I did this. Oh, yep, gotta put that in parentheses. Like, yay. And we're gonna have to put this code inside of these, what we call alpha braces. And what this actually does at this point is anything that's in here is just going to be Objective-C. It's not gonna, well, I guess we'll have to prove that it's Objective-C some other way, but in this case, we're just gonna do return A plus B, just like we did the other way, right? And this is now currently only going to work on iOS and desktop. It's not going to work on Android. So if we go in here, rebuild this and run, see how we broke it this time. Okay, seems okay, seems okay. And like recruited, we do something here, and it says .NET, right? So it's calling add, but it's using the .NET implementation in this case. But we want to see what it's like when we're on iOS, right? So instead of calling debug log, we're going to call nslog. I guess iOS, just like that. It's science. And with that, we can go here and do a preview on iOS. Of course, this is going to chug for a little bit here. But you can sort of, while this is spinning up, you can sort of see the philosophy here, right? Like, you are writing Objective-C that can obviously talk to other Objective-C code. So if you think about the round trip here, from UX markup, we are setting these properties that are in turn calling this add function that in turn is calling Objective-C code, which could talk to whatever Objective-C code you want. There's, clearly, I don't want to turn this into like a foreign code stream, but this is the bridge. This is how you make a node that talks to native code. So, hello. Let's see what we can see today. Let's see what I broke. Full disclosure, I'm not super confident with writing Uno myself, so I've been expecting to get all kinds of compiler errors. So far, so good. Of course, compiling takes a million years. This is why you want the preview app and hopefully not rely too much on writing this Uno code. Like, generally speaking, as like a philosophy, we're sort of trying to move as far away from Uno as we can. But at some point, you're going to have to write something native, right? And so it's sort of like this inescapable little bit of complexity. So we're hoping, like we were having discussions even today, like there's got to be like UX ways we can handle this sort of bootstrapping of native stuff. So we're always thinking about like nicer or like friendlier ways to do this. But if you've been doing sort of foreign function interfaces using stuff like maybe hacks or anything else really, I think the way we're doing this, like we're taking Uno doubles and we're handling like the type conversion for you. So when you get into iOS world, these are NS numbers at this point, right? And the return value is again being like changed back into a Uno double. So we're doing a lot of the kind of boring work for you in just getting the interface up. Let's see what we got here. Yeah, we have a lot of, I mean, yeah, the history of the company, like Uno, was the product. Like like in the beginning there was darkness, right? It was like Uno was a like graphics programming platform. Like it's a language you write to do like cross-platform, like cool looking stuff. But you were writing Uno, and that's kind of it. And we've been sort of building like platforms on top of Uno ever since, and most recently like culminating in the Fuse platform. So Uno is a very mature language for what it is. It just so happens that it's been shaped primarily by our needs, right? So it's become sort of like this, the tool that we use to build Fuse. But being open source, it's really cool to be able to give you guys the ability to extend the platform in your own ways, right? Like, so the reason we make something like Fuse Labs public isn't just to like, tick the box and be like, we're cool open source people. It's like, we do want you guys to pitch in and help and give feedback and take part in building this product. But clearly, like, kind of learning Uno, if you know C sharp, it's basically C sharp. It's C sharp with some stuff in it. It's like, I guess the best description I've heard was it's a dialect of C sharp. So for what it's worth, it's a pretty like nice language. Like it's not this unknown weird thing that we just made up. Hey, or let's see what we got here. Let's see what we got. Gotta start the emulator. Hoi, hoi, hoi. Gotta start the app. Gotta do all the things. And I guess I have to view the output. God, I'm not a huge fan of Xcode, I have to say. Oh, here we go. So let's just put something in one of these guys. There we go. So it says custom node iOS, right? And I mean, that's not the greatest demo in the world. It's like, lo and behold, it says iOS. Look at that. It totally says iOS. That's the culmination. But it's, I still think it's a pretty cool thing to be able to do, right? We're showing like this really, really simple way to get from this markup into something that calls a native function. So hopefully that gives you a little bit more clarity. So I guess, unless you guys have more questions, I think that's gonna be it for this stream. It's really winding down for the Christmas. Like everyone's going on vacation, me included. So prediction is we're probably not going to be kind of streaming at the same rate until January. But I, hope you guys will have just a wonderful Christmas. Happy New Year. It's been a pretty rough year. But I'm confident we can do the next one better. And yeah, happy holidays, and I'll catch you all on the flip side.